So a time that, okay, oops. Okay. Good evening. My name is Ron Grimm, and I'm the Vice President and Program Chair of the Washington Map Society. I'm standing in to welcome you for Jeff Katz, our President. He is currently in New York City with his 97-year-old mother who's been hospitalized. So our thoughts are with him tonight. Welcome to today's program, which is hosted by a partnership of 6 map societies representing all parts of the country: California, Chicago, New York, Rocky Mountain, Texas, and Washington map societies. These map societies are nonprofit organizations that support map collecting, cartography, and the study of cartographic history. These groups also supply financial support for these Zoom meetings. If you are not a member, we hope that you will consider joining at least one map society. Benefits for each society vary. For example, members of the Washington Map Society receive 3 annual issues of the Portland Journal, digital access to all past issues of the Portland, and digital access to guest speaker lectures, and many other features in the members only section of our website. If you are not a member, the Washington Map Society has an introductory rate of $25 for 1 year of a digital membership. We and our partner map societies would like to thank our advertisers who support our groups and also help make possible the publication of our journals, the Portland and Calafia, the Journal of the California Map Society. Before we proceed further with tonight's program, here are several requests for this Zoom presentation. Please note this lecture will be recorded, so please turn off your video and microphone if you do not want to be recorded. Please use the chat feature to type questions, and they will be addressed at the conclusion of the talk. And after the question and answer period, we will leave the meeting open for attendees to socialize if they wish, at which point you may turn your microphone back on. In consultation with other map societies, we have developed a schedule of monthly Zoom meetings through the beginning of January. This schedule has been listed in the current issue of the Portland, and I have circulated it to the program chairs of the other map societies. The next combined map society Zoom meeting is scheduled for Thursday, October 27, starting at 7 p.m. Eastern Time. It will feature Laura McElfresh, cartographic metadata librarian in the university libraries at the University of Minnesota. The title of her presentation is "Will Work for Maps: A History of the Library of Congress Geography and Map Division Special Map Processing Project." It is based on a lecture or on an article that she and several other folks recently published in the Journal of Map and Geography Libraries. It was co-authored with Paige Andrew and Linda Musser of Penn State University. In her presentation, she will review the Geography and Map Division's Special Summer Map Processing Project's origins, its structure, its impacts, and its outcomes. It had its origins after World War II, when the Library of Congress Geography and Map Division acquired large quantities of military-related maps through the U.S. Army Map Service and similar agencies, resulting in many duplicate cartographic materials. To manage this surplus, the Geography and Map Division founded its Special Map Processing Project, recruiting hands-on staffing assistance from geography students, faculty, and librarians in return for their labor. Project participants selected surplus duplicate maps for their home institutions, thus strengthening, enlarging, and sometimes seeding map collections throughout the United States. I encourage all to attend this. It is a lecture that not only touches the geography and map division, but touches map collections throughout the country. Now, this meeting was originally organized as one of our regular Zoom meetings in association with the Philip Lee Phillips Society of the Library of Congress. Since we did our original organization, the Phillips Society has scheduled several in-person events at the Library of Congress on the afternoon of October 27. There will be a lecture from 3 to 4 by John Hessler looking at the history of election maps. There will be an open house and reception in the Geography and Map Division. And then at 7 p.m., we will have this presentation. At the moment, we will try to have Laura travel to Washington, D.C. and do the lecture in person. And if we do that, it will be broadcast, it will be live streamed, so all the rest of you can attend through a Zoom or live stream format. So we will be getting the publicity out on the exact logistics in the next few days, so please pay attention. And now it is my pleasure to introduce this evening's speaker, Les Trager. He is a retired lawyer and a member of the New York and the Washington Map Societies and the Explorers Club. His previous book was Henry Hudson, Cree History and Ancient Maps. He has done several articles entitled Mysterious Mapmakers, Exploring the Impossibly Accurate 16th Century Maps of Antarctica and Greenland, and Isostatic Rebound in Lower James Bay, and Locating Thomas James Henry Hudson's Camps. Tonight's lecture was organized in association with the New York Map Society. The title of the presentation is Maps of Ancient Explorers and Climate Implications, and it's based on his recently published book, Ancient Explorers and Their Amazing Maps. He will discuss a body of Western 16th century maps which cannot be explained by the discoveries of European explorers. He will show that the leading 16th century map makers understood that they were copying maps by the ancients. And again, if you have questions, you may type them in the chat feature during the lecture. He will address a few of your questions at the conclusion of the presentation. I now turn the program over to Les.
Thank you very much, and good evening, all of my fellow mappers. Today I'm going to go into the lecture as Ron described it, and talk about these early maps. And the first thing I've got to do is to share the screen here. And there we go. And now there's just one more icon that I have to hit. All right. And now we've got it enlarged, and I can go forward. So, as Ron said, the thesis of this book on which this lecture is based is that there are these maps of ranging from the 13th through the 16th century that really can't be explained by known explorations and also by scientific knowledge of the Europeans during this period. And as you can see here, the map on the cover is of Antarctica, but then the critical thing here is this map we'll see is from 1531. There's no ice anywhere on this map at the borders of Antarctica. So that presents a rather a mystery, and that's why it's on the cover. This is the map that I took the map of Antarctica from. It's the Phineas World Map of 1531. And here is Antarctica over here. South America is down here, and Africa is over here. And this is the Ross Sea here, but in place of the ice shelf and glaciers here, we have free-flowing rivers all around. Here is where the Thwaites Glacier resides today, but in place of it, we have a body of water here that, the Thwaites Glacier is called the Doomsday Glacier if it melts. And down here, we have the Weddell Sea, just at the tip of South America.
Les, your voice is muted.
I'm sorry, we okay? Okay.
Oh, could you speak closer to the microphone?
Oh, I'm sorry. Okay. You're not hearing me. Is that what you're telling me? I'm not muted. Can you hear me now?
I hear you easily, Leslie.
I'm sorry. You hear me, everybody?
Yes.
I hope.
Coming through well.
Okay. I mean, the
Yes.
microphone is part of the camera, so I can't be too close or I'll be in the taking up the camera, as it were.
We hear you well. I suggest people listening turn their volume up on their computers.
Oh my. Say the volume you want
No,
to.
you're okay. You're fine, Leslie. You're fine.
Okay. So if it's okay with everybody and we can hear, I'll talk loudly and hopefully everybody can hear me. Our next map is what I call the Stuttgart Gores. They're gores that were found in a castle in Antarctica, rather in Germany, Stuttgart, Germany, and they show Antarctica. And I put the gores together so that we could see the map that it makes. And particularly, I want to focus here on the Ross Sea. You can see here at point A, there's a little island here. There's a free-flowing river here. And here's another island with a river looks like in here. And on the coast are our islands are just off the coast. Well, that's rather consistent with what we see in a map that shows the outlines of Antarctica as it would look without ice. So the red line here is the map of Antarctica without ice. It's a current map. And all the gray area represents ice. And so here we see that same little island at point A. We see another river here. We see an island over here at point B. And here are these islands off the coast at point C. And in fact, it lines up rather nicely with the overall shape of Antarctica. We can compare the two side by side. And the only thing that's missing from the Stuttgart Gores map, as well as the Phineas map, is the Antarctic Peninsula, which is up here. And of course, no one really knows why that peninsula doesn't show up. But aside from that, it's a rather accurate representation of Antarctica. Now, obviously, nobody could get there in the 1530s or any time prior to recent time prior to that. So the question is, well, how are these maps made? Now, present science tells us that the last time the coast of Antarctica was melted was about 115,000 years ago. Well, it seems highly unlikely that anybody, early man at that time, could have made maps, much less pass them on to almost the present day. So what's the other explanation? And that seems to be that they had to be made at some point within historic times. In other words, within the past 5,000 years. And the implication from that is that that would indicate that, in fact, ice melts and reforms a lot faster than we think it does. So that probably would indicate that the ice around Antarctica will melt faster than is currently predicted, which would further indicate that we can expect sea level rises from the melting of this coastal ice. So how do we know when these maps were made and if they were made in historic times? And it seemed to me that we ought to look and see if there are any other maps that can't be explained by known exploration and try to find out when some of these maps were surveyed. And there are many European 16th century maps which cannot be explained by any European exploration. And to me, this demonstrates that at some period in ancient times, when Antarctica was in fact melted at the coast, there was some exploration and making of maps. So turning to these maps, our first map is Greenland. This is from the Mercator map of 1569. And we can look at this map and see here is Baffin Bay in here with its turn to the west. And here is Independence Fjord right here up in northern Greenland with that little bump that we'll talk about in a moment right here. And this is the fjord and the body of water next to it. And we can see that if we look at the present map of Greenland, that it's the Mercator map is not bad. Here is the Baffin Bay again with the jutting out of the land to the west. Here is Independence Fjord up here. And this is the same overall shape that Mercator shows, except that Mercator shows it without ice at its coast and with lots of little islands and things along the coast, something that we don't have in our current maps. And up until the end of the 19th century, nobody knew what the northern end of Greenland was. We just hadn't been able to get there. The geographers thought that it was probably a peninsula attached to Siberia, or else there were little islands at the northern end that went almost to Siberia. We didn't get to northern Greenland, I say we meaning the European explorers, until 1891-92, when Robert Peary got to the northern Greenland coast and saw where it ended. And he got there by dog sled because you couldn't sail there still. So that shows that we couldn't have possibly made the Mercator map based on any knowledge that Mercator had or that of current explorations and anything up to the present time almost. Here is a map just to show you the accuracy of the Mercator map. Here is Independence Fjord. It's a detailed map made about 1940. And this is Independence Fjord here. And here's that little hook of land that I referred to. And here are these islands off the mouth of the fjord. We can go back to here again and look and see the same hook right here on the Mercator map and these islands at the mouth. So it's a pretty amazingly accurate map for no one who had been there, certainly. We can go to other maps and look at them too. The Volsamiller map, 1507. This shows both North and South America. Here is North America here, and it shows the West Coast with mountains there. And here is South America here. It shows the bend in South America. It's a funny projection, but there it is. And it's quite an accurate map of South America. Longitudinally, I figured that it was within 1 degree of being correct longitudinally. And that was something that Europeans couldn't do in 1507. Again, another map of South America, early map, is from the Lennox globe. This is a drawing based on the Lennox globe. And this is the west coast again of South America, except that the tip it curves to the east, probably as a favor to Portugal, so it could claim it. In any event, it shows the west coast also of South America. Nobody was there. In fact, Balboa, we know, didn't see the west coast, much less explore it, until 1513. And the west coast of North America, the explorations were even later than the coast of South America. Here is the North American section of the world map by Juan Lacosta, 1500. And here is Florida down here. And then you can see a rather familiar coastline going up here to North Carolina. And here is the Gulf Coast along here. Not a perfect map, but in 1500, 4 years after or so that Columbus got here, no one had gotten to North America from Europe to explore it, at least this section of it. And Lacosta didn't really know where he was at that point. He actually thought that Florida was Cape Race, Newfoundland. And I think the reason he thought that was he had a map from John Cabot that showed Newfoundland, or at least part of it, and it undoubtedly showed Cape Race. Cape Race is a peninsula which points southeast, just the way Florida does. So Lacosta named the Cape here, Florida, Cape of the English. And he decorated the Gulf Coast here with English flags. Our next map is the map by Diego Ribeiro. It's a world map, and this is the North American section. And we can look here, this is Florida here. We go up here, here is this is the level of North Carolina, and then this is the rest of the East Coast up to the Gulf of St. Lawrence. And what's particularly interesting is if you look right here, this is a cape at the level of North Carolina. But no such cape exists today, nor did one exist in 1529. There was one exploration at that point by someone called Estevia Gomez, who's referred to in this map. But Estevia Gomez, we don't have no records from the sail that he did in 1524, I believe, from Cuba to Maine. And there are a lot of things here that he wouldn't have recorded this way if he had actually studied the land at all. So here's this cape that I mentioned a moment ago, and it doesn't really exist. Here is the same area, a detailed map, and you can see that here are the outer banks. So that's the perimeter of the section of the North American East Coast. But if we draw a line at the 1 meter line, 1 meter above present day sea level, we see that the outer banks disappear, and we have a cape here, a cape with a river. This river is called the Neuse River, and there's another river right here, the Palico River. And this is very consistent not only with the Ribeiro map, but with the map by Alonso de Santa Cruz in 1542. Both Ribeiro and Santa Cruz worked for the Pardon Real, which was the headquarters for maps in Spain. And so they would have had access to similar information. Well, here, this section of the map, it's a map of many parts of the world. This section of the map here is North Carolina. It goes up also to the Gulf of St. Lawrence. And looking at this cape, if we look along here, we see that there's a river coming in here and running alongside the cape. And of course, there's another river here, and these are both these rivers are consistent with the way the land would look at 1 meter above sea level. If, in other words, if the sea level were 1 meter higher than today, and it could be up actually to as much as 3 meters higher than today, and it would still look roughly consistent with the Santa Cruz map. So to me, that indicates that when these maps were made, Antarctica ice and Greenland ice had melted to a large extent along the coast and raised the water level so that the outer banks disappeared. And we have this cape with these islands here that are, as I say, very consistent with the way it would look at 1 to 3 meters above present sea level. There are the two rivers I've talked about, the Neuse and the Flamenco, and they're both shown in the Santa Cruz map. Our next map is the Contarini-Rosselli World Map of 1506. This is the Americas section here. We can look at that, and this is the coast of North America, the East Coast. And what's interesting is there are mountains here along in the East Coast area. And of course, no one in 1506 had done any exploration of the interior. And then we go farther inland and we see a great plain, flat. And then over here in the west, we see more mountains. So that would indicate that somebody had done some interior exploring at a much earlier time. Interestingly, the west beyond these mountains is shrouded in clouds, probably because Contarini and Rosselli weren't sure whether North America was attached to Asia or not. There was a big controversy at that time as to whether it was, but nobody had any real idea in terms of exploration. Our next map is the Ortelius world map of 1564, and this is the northwest corner of the map, and this is the northwest corner of North America here. This is the Alaska here, and we have the Alaskan Peninsula there. There's an island in the middle, and here is Siberia over here. So what we're looking at here is the Bering Strait, drawn in 1564. And here is a comparison map. It's a little different projection. So, but this is the Alaska down here, and we have the same island in the middle here, and then Siberia over here. Well, Bering didn't get there until 1741. The strait is named after him. And when he got there, he found he crossed it to Alaska, but he didn't do much map making. It was a very harsh and difficult journey. So it's clear that no one from the West, the Europeans, had been to this area by 1564, but here's this map that shows the division between North America and Siberia. We really don't have to speculate, though, as to whether these maps are based on ancient knowledge, because Mercator tells us that explicitly. This is a translation as to what he wrote over the North American continent in his world map of 1569. And we have to read that to really appreciate what it is. The third aim that we had in view was to show what parts of the world were known to the ancients and to what extent, in order that the limits of ancient geography may not be unknown, and that due honor may be paid to the earlier ages. He then continues after citing voyages mentioned by Pliny and Herodotus. It is clear then that our continent is surrounded by the ocean, and that its extent was known to the ancients, and it is evident on their authority that it was in large part described. Plainly, those persons are mistaken who make New India contiguous with Asia. Now, our continent refers to both North and South America, because he called both North and South America New India. So when he says our continent is surrounded by ocean, that of course is clearly correct, because if you look at a map, you'll see that the North and South American continents are surrounded by ocean. And there are many other early cartographers who refer to the ancients, but Mercator in this particular passage is the most explicit that he's relying on these earlier maps. So now then that we've seen that there are these early maps, our next problem is to date them. And for that, I turn to Hudson Bay. And I turned to Hudson Bay because it is a very unique area in the world that has been subject to a lot of glacier ice during the Ice Age. And when that ice melted, the land, which had been pressed down by the glacier, rose. And we call that isostatic rebound. And we can date things if we can figure out when the maps from Hudson Bay area were made based upon the sea level changes over the past couple of thousand years since the glacier melted. That isostatic rebound has resulted in beaches, some of them a couple hundred feet in the air, and the rebound is continuing even today. So our first map and the earliest map of Hudson Bay is the 1531 Phineas map that we looked at earlier. Here is Greenland shown by Phineas. It's a similar outline to that by Mercator, not as detailed, but there it is, same outline and very accurate. And then we go across through the water past a couple of islands, and we come to the Hudson Bay. And this is Hudson Bay here, this body of water here. If we go down here, that down there, that's is James Bay here. This point of land is the northwest corner of James Bay. And if you look at this corner, you'll see that after the going up here to the point which we call today Cape Henrietta Maria, it goes southwest, slides down to the southwest, and then rises again. And here is a river consistent with the Nelson River in this corner of Hudson Bay. And up here is another river consistent with the Churchill River. So this shows Hudson Bay, but as we see, it shows it at a much earlier time. Henry Hudson didn't get there, of course, until 1610. This map is almost 100 years before he got there. And our next map, which we'll study in detail, is the Champlain map of North America, 1632. This is what I'm pointing to here is Champlain's rendition of James Bay. And if we go here to the left, this is Hudson Bay, the approximately the first third of it. And we can see again that cape up here, the entrance to James Bay, and then that dip of land down to the southwest. And here is James Bay. We see this peninsula surrounded by islands. Well, the land doesn't look that way today. It's quite different. And we can take a look at the present day map. Here is Hudson Bay today, and James Bay down here in the lower part. And then this is Cape Henrietta Maria here, the northwest corner. And we see that the land pretty much goes straight across before rising up to the Nelson River here. Champlain never got to Hudson Bay, so he based his map on some other sources. And in general, we don't know exactly what those sources were that give us this detail. But here is a map that I've drawn of James Bay at the 110-meter line. In other words, this is what the way James Bay looked when the land was 110 meters lower than it is today. And So we can see the body of water in the middle here. That's the present James Bay. And then here is the peninsula, and there are islands surrounding the peninsula. And we can see them here in this picture. There are no such thing. These islands and a peninsula like this doesn't exist today. So we'll compare that now to the Lower James Bay, to the Champagne map of the same area. And here we have this large island here, another large island here, and these other islands off the peninsula. Also, it's interesting that the bottom of James Bay is today 51 degrees 16 minutes. The bottom of James Bay, and this at 110 meters, is 50 degrees 6 minutes north. And the bottom of James Bay in the Champagne map is 50 degrees 30 minutes. So obviously Champagne was making a map based upon information that was not gathered anytime around 1632. I might add the maps that I'm showing you here, such as this 110-meter line, were made using the app GeoMap app from Columbia Lamont Doherty Institute, and that map allows you to, or that app allows you to make maps of any meter line that you desire, almost anywhere in the world. And so it's a very good facility for looking at maps and looking at earlier geography where there's been this sort of uplift. Our next map that we're going to look at is the northwest corner, and compare that to the Champlain map with the meter line, which I've drawn here at 118 meters. And that seemed the most compatible. And here we have a very interesting comparison because it looks quite similar. We can go here to point A, and we see a river down here in the bottom, and this is a similar river here. Point B, we have another river next to it. C, there's another river. Champagne is an extra one in between, or maybe a bay. But here's point C, which seems compatible with this river here. And then this other river here, we have D, which Champagne has here. And then we have this island off the coast, point E, and we have another similar island here. This area is known as the Sutton Ridges. You can look down here, and here's this U-shaped sort of thing surrounding, I guess, some sort of other rocks. But anyway, there's you have this division here, and Champlain reflects something similar with his U-shaped sort of harbor in here at point E. So I felt that these land rises, that the Champagne maps reflect land when it was between 118 and 110 meters lower than the present time. So now the question is, well, how to find, in terms of date, when that land, this land was 118 meters or 110 meters lower. And the present measurements using GPS for Lower James Bay shows that the land in Lower James Bay is rising at the present time 1 meter per 100 years. But we also know that rebound is faster nearer the glacier melt than it is today. We know that because we can look at the raised beaches, and they're farther apart at higher elevations. So therefore, we have to find what the rate of decrease was in order to compute how far back the surveys probably go. So to that, I turn to Thomas James and his very accurate description of his ventures in exploring Hudson Bay and James Bay. And he was there in 1632. He wintered over, and he describes where he wintered here. And this is on the place called Charlton Island in Lower James Bay. And point A is where he camped. And then he describes a nearby river, and this is certainly compatible with that river, point C. And then he describes something very unique. He said there was a harbor which he wanted to use to put a ship in for the winter. And he said the harbor was 4 fathoms deep, but that he couldn't enter the harbor with a ship because there was a bar at which at high tide, the water was only 2 feet deep. So he was disappointed in that one. But now the question is, where is that harbor? Well, we don't see any potential harbor in this area along the coast here today. But if we draw a line at the 5-meter line, we can see such a harbor appearing, and that is point B right here. So I did some further study of this harbor, and this is what the harbor looks like today from Google Earth. Here is the harbor, here is the entrance to it, and today the stream flows down to the sea. So what I did was I wanted to see what the profile of this harbor was. So I could use GeoMap app to do that, and I made a profile from here to the mouth, the entrance. And this is the profile which I made. And you can see that the depth of the harbor is approximately 4 meters. 1 meter here and 5 meters up here. So we know that the depth is 4 meters, which is approximately the same as 4 fathoms. And then here is the entrance. And you can see now there's a bar here. It rises approximately 1 foot above the 5-meter line. Well, there's a 6-foot tide in the area, which means that the 5-meter line represents mean average sea level. So you will have a tide that's approximately 3 feet at low tide, 3 feet below, or almost at the 4-meter line for low tide. And in high tide, you'll have 6 foot tide. And that will be 3 feet above the 5-meter line. Well, with the bar there at 1 foot, you end up with only 2 feet of water at high tide. And so we find that the description of James perfectly fits this harbor here at the 5-meter, found at the 5-meter line. I also examined Henry Hudson's campsite description, and they said that there was an island that they camped in nearby here, about 30 miles away. The island doesn't exist anymore, but if you go to the 5-meter line, such an island appears, and you can see that it's very compatible with the campsite described by some of Hudson's men. So that indicates that over the past 400 years, the actual sea level rise has been 5 meters. But on the other hand, the present rate is only 1 meter per 100 years. So that at the end of 400 years, that would be only 4 meters. So we know that land 400 years ago was rising faster than 1 meter per 100 years. In fact, it was rising at 1.4 meters per 100 years. And from that, we know that the rate of decrease over the past 400 years is 0.1 meter per 100 years. or 1/10 of a meter per 100 years. With this information, it is now possible to go back and calculate how long it would take to reach the 110-foot line. In other words, for the land to rise 110-meter line. In other words, for the land to rise 110 meters. And I did that calculation, and it came out to 3,750 years. And so that seems to be the date when it would appear that these maps were surveyed. And that date is certainly an approximate date, is a reasonable one historically, because first of all, it was the height of the Bronze Age Middle Kingdom in Egypt, and that was an era when such explorations possibly could have been done. It's also consistent with a lot of the data that comes out of Antarctica. So we know that 5,000 years ago, the water temperature around Antarctica was twice as warm as it is at present. And 4,000 years ago, it was almost the same. 2,500 years ago, it was 1/3 warmer than present. And we know that it's the water that is the most important thing in terms of melting ice. So if you have warm water, you're going to melt ice pretty quickly. In Greenland, the data is also compatible. The maximum warm period for Greenland was between 4250 before present to 3750 before present. The tree line in Canada was farther north than it is today. People lived at Independence Fjord between 4350 and 3950 BP. On the other hand, if you try to date the rebound using carbon-14 of seashells, which has been the traditional method for trying to determine how fast land has risen in this area of Hudson Bay, you find that for 100 meters, it would take 5,000 years, according to the carbon-14 data. Well, that doesn't work historically. Most importantly, 5,000 years ago, Antarctica had twice as much ice as it has today. The Ross Sea ice shelf was double the size of the present ice shelf. And of course, when you have a bigger ice shelf, you have bigger glaciers because they support the ice shelf. So no one could have sailed to Antarctica 5,000 years ago and found it to be ice-free at the coast. So the significance of this in terms of our climate is that it shows that, to me, it shows that ice is melting in Antarctica faster than we presently think, because we think that Antarctica was never melted at its coast, when in fact these maps show otherwise. And it shows that this large amount of ice around Antarctica melted in approximately 1,200 years. So that would be something new, I think, for science. I finally want to show you this picture of a ship. It's a ship that Ron Craven saw. I call it the Craven ship, when he was flying in supplies to various radar stations in the Hudson Bay area along the mid-Canada line during the late 50s and early 60s. And this is a picture of the ship as he showed it, as he remembered it. And it's got this crushed deck and this type of thing, but it's clearly some sort of ship. It would be good if we could find that ship. Based on the data that he gave me, I probably know where it is within half a mile. And if we could find it, then we'd be able to know more definitely the time period when there were ships from some ancient civilization sailing in this area. And we'd also be able to and we'd probably know who was doing it, which we don't know at the present time. And I would love to get a hold of a NASA satellite that could give such resolution so that we could find this ship. I hope that you've enjoyed this lecture. I hope also that some of you will be interested enough to go out and buy my book. It's available online, both digital form and in hard copy. And for those of you who want to communicate with me afterwards, at some point about maps, I'm happy to discuss them. This is my email address, lestraker22@gmail.com. Thank you very much.
Okay, Wes, thank you for an intriguing talk with some interesting hypotheses. I did get a sense that maybe some people aren't quite sure what rebound is. Could you explain that a little bit for our
Sure.
non-geological members?
Sure. Rebound is the land that was pressed down by the glacier. The weight of the glacier pushes down on the earth to such an extent that it is put hundreds of feet down, and the ice is on top of it. When the ice melts, the land rises up, and the rising up of the land, the rebound of the land, is called isostatic rebound.
Okay, here is a question from Paul Emmigholtz. Could land lifting in Canada have stopped North Pacific current that perhaps 5K years ago might have flowed across Canada? Current brings warm water from Japan, which is why parts of Alaska and Washington have warmer beach water than California most of the year. I'm not sure I read that properly. Did that make sense?
You read it correctly.
Okay.
Okay, do you want me to try to answer that? Because I'm not really sure that I can. I mean, I recognize that there are many other factors in melting ice, and we're constantly discover new ones. I'm trying to look at it historically and say what these maps mean. And this is something that we haven't quite found yet, but I think it's consistent with what they are finding gradually.
Well, and just to clarify the question, it's based on Dr. Spencer's research that, essentially when the ice melted, the southeast part of the continent dropped thousands of feet over the last 13,000 years. And correspondingly, the upper part of the continent would have had to lift. And there's large parts of, Canada that are fairly low lying. And, the North Pacific current is basically coming right at Alaska and then it's forced to the south. And so if it were to flow naturally across, it would, melt ice near the coast.
Yeah, I mean, but what is that? Okay.
So I'm just wondering if that might explain the Arctic, being shown with ice not on the coast.
Well, I don't think so, because we're looking at a lot of other maps and we're looking at Antarctica too. So that's why I don't think it particularly explains that.
Okay. Greg McIntosh asks, how was the accuracy of the maps you claim determined?
You mean as like, for instance, the Volsa-Miller map? Or which map are you referring to? There's some of them are.
Well, yeah, my question is, you have presented many 16th century maps and claim that they are accurate.
Well-
I'm asking how that was determined, since accuracy is something that's, mathematical, if you will.
In most cases, of course, it's visual. You look at the maps and you see that they outline a particular area and that their topography is similar to another area, so that is an accurate map, and that's how I would do that. It's not a one-for-one thing. On the other hand, if I'm talking about the Volsamiller map, where you're talking about the longitude of South America, that I attempted to measure based upon the Volsamiller map, comparing it to what we know today. So that would be the way it's being done.
Okay, then, thank you. That was my question. Thank you.
Okay, there's several thank yous, and now a question from Ben Olshan. Could you talk more about who you think generated the prototype maps here? What cultures and methods were involved?
I wish I knew, but it honestly would be speculation on my part. I will just say that to me, to mount such an ambitious campaign of sending ships around the world to make maps, particularly of some place like Antarctica, which is just, even if their weather was warmer and there was no ice at the coast, you're talking about darkness for a long period of time in the winter. It's just not an easy area to map and to get to by sailing. So whoever was doing it had to have a lot of resources to do this and be willing to spend the funds. My best guess, and it's only a guess, but I nominate Egypt because it had a lot of wealth at this time and was much more wealthy than other countries. And the other reason I nominated is that with respect to earlier maps, it's very interesting, but if you read my book, you'll see that there's a globe in Germany from about 1530s again. And on that globe is a depiction of a early Egyptian sailing ship dating to about 3000 BC or 5,000 years ago. And while that time is not relevant to what I think when these maps that we discussed with respect to Antarctica were made, it shows a certain interest in sailing and in exploration. And that's apparently how that depiction of an early ancient Egyptian ship got onto a globe. It must have been copied from some other map. We don't know what map it was copied from, but it's there and it's rather intriguing. So that's all you can say. I want to find Ron Craven's ship, and then we'd have maybe a better answer.
Okay, Ronald Decker asks, is there any evidence of ancient animal bones along these Arctic and Antarctic coasts that might confirm these different sea levels?
The answer is that there's just, the data is very, very not only sparse, but most importantly, it varies a lot. If you look at the data from the shells, which is the most widely available, in other words, shells found on these raised beaches, and do the carbon-14 data, you get fairly wide results. And when you compare that to a few, and the problem with carbon-14 of sea animals is that it's very different. There's what's called a marine reservoir effect. And that is carbon in water lasts much longer time than it does in the air, with the result that the sea animals are taking into their bodies, into their shells, carbon that's much older than it would be if they were living and breathing just air. So that's why one of the major reasons why it's very difficult to use these shells and to get it. And that's why I turned to trying to find it historically. And I did that using, as I say, the James Bay Area, and I think it's much more accurate than trying to, if you look at the data, and I have a lot of it in my book, it's rather a mixed bag, and you can see great inconsistencies in the data. So it's very hard to smooth that sort of stuff out. But that's why it's not, I went to the historic data that I could get.
Okay, a question from Stephen Nagler. A question about the maps that you speculate show Antarctica without ice. What do they depict in the region of Australia and New Zealand?
You mean maps of Australia?
In other words, a map that you use to say that it shows Antarctica, what does it say about Australia and New Zealand?
We don't have a map that's anywhere near detailed of Australia or New Zealand. I mean, there may be a map. People have argued about such maps they say are Australia, but we don't really have a map that in any way matches what we have, the maps I've discussed.
Okay, Lance Kunzer asks, would it be fair to say that sea levels are rising at 1.4 meters per 100 years right now?
No, sea levels are not rising at 1.4 meters per 100 years. We talked about land, and that was land rose in Hudson Bay area, lower Hudson Bay area. I calculated that land was rising at the rate of 1.4 meters per 100 years. Today, it's rising at the rate of 1 meter per 100 years. And it's the land that is rising. Sea level, for practical purposes and for purposes of this study, is considered level. It's true that sea level will rise, but the rate of sea level rise is nothing compared to what the land is doing. The land was pressed down hundreds of feet. Greenland, if you suddenly took all the ice away from Greenland, it would end up with as an archipelago actually at this point, because until the land rises, it's pressed down. And a lot of it is below sea level, and that's also true of Antarctica. A lot of the land is still below sea level, particularly near the coast.
Okay, Lewis Kennedy asks, are the accuracies of the 1500s maps unique to these presented maps, or do you find additional maps with these ancient accuracies?
Oh, there are many maps that have that have features that show other maps that show things as they existed at some earlier point. Some of the most intriguing maps are maps showing the link between the Hudson River and the St. Lawrence and the Sea of St. Lawrence, something that existed a couple thousand years ago, maybe. We're not sure exactly of the dates, and I don't have good data on that, but there are these maps that show that, and it's very, very interesting.
Okay. Ben Olshan responds, an Egyptian conjecture is interesting. One would have to show a line of knowledge transmission, then from a set of hypothetical Egyptian maps up to the 1500s. Interesting. So I'm not sure if that's a question, but just a comment.
Yep, aren't there yet.
Okay. Okay, Doug McElray, you noted the absence of the Antarctica Peninsula from the first two maps. Is there a plausible explanation for that?
Probably the best explanation that I think is that Antarctica, as drawn on these two maps, is too large compared to the rest of the world. And so the result is that because it's enlarged more than it should be, the Antarctic Peninsula, if they'd drawn it all the way, would have bumped in and overlapped with South America. So probably they just simply eliminated the Antarctic Peninsula because they didn't understand that they had drawn it too large.
Okay, there are quite a few more questions. I'll take one more. And I would suggest to the other people you had Alessa's email, maybe you could send those questions to him by email. Okay, Tim Weiskell comments, the rising and falling of sea level would have a global or at least regional correlate. This would be registered in the geological history of large stretches of coastal regions around the world. What is the geomorphological evidence of sea level variation corresponding to the changes you are suggesting from cartographic anomalies could have occurred?
Yes, the answer is that we know that sea level was higher in the past and than it is today. And it was higher a couple thousand years ago. The data as to exactly when the sea level was higher is hard to correlate, but it certainly was. We can look at studies showing, for example, the one that I recall, and there are a number of them I mentioned in my book, that of India, where the sea level was found to be higher. And in fact, there's the I forget now the name of the site. It's a World Heritage site in India, and it's very interesting because it's all these cities were once on the coast there, and now they're not. They're nowhere near the coast, but there had to be water coming around these cities. So in order to do that, you had to have higher sea level, and you know, that's an indication of the prior higher sea levels.
Okay, well, Les, I'd like to thank you for this talk. We have some gifts to send you, some cartographic note cards and an outline map, I think, of Cape Cod. I understand that's where you're living these days.
It is.
And I'll send you a message asking you for your address. So at this point, I would say if you have some comments or questions you want to raise in the next few minutes, go ahead. Otherwise, thank you everybody for joining us tonight. And I look forward to you joining us in some of our future meetings this fall.